Welcome, everyone. Thank you for coming to our talk. Today's talk is focused around how at Box we are promoting data democracy and driving adoption of data-driven culture. We will share the best practices that we've employed for our Hadoop infrastructure to further the same. David and I are part of the data infrastructure team at Box. In our role, we're responsible for managing and scaling the Hadoop data warehouse. In addition to that, we have responsibilities for scaling and managing Elasticsearch, HBase, Spark, and all the other portfolio of technologies that are common on data infrastructure environments. For those of you who are not familiar with Box, Box's vision is to enable users to securely share, manage, and access their content from anywhere in the world on any device. We have 32 million unique users, counting across 275,000 unique businesses, and Box is trusted by 99% of Fortune 500 companies. Box is well trusted in the industry vertical space. We are partnering with the major industry verticals to develop customized applications suited to those verticals to add value just beyond storage. So this was a little bit of an overview of what Box is. Now we jump into the main body of our talk, which is how do we think outside the box at Box? The mission statement for our data infrastructure team is that we want to build a reliable data infrastructure that is simple, fast, and economical to scale. These were the guidelines that we set for ourselves when we started noticing that we had substantial scale challenges, and the existing approaches that we were taking to scaling, managing, and helping our users were becoming bottleneck. At Box, we have a variety of groups and teams and users that use the Hadoop infrastructure to solve their challenges. The teams that rely on Hadoop span anywhere from customer retention, malware detection, data warehouse, content classification, as well as security. So what we're finding is as more and more use cases are coming about in the Hadoop data infrastructure, so are the challenges. Okay, and just to give you an overview, we have a fairly complicated architecture. We collect a lot of data from a variety of sources. These sources are anywhere from telemetry data, which is monitoring data, to logging data, to event-driven data. We collect all the data sets, and we store it into a centralized Kafka cluster. The idea there is that we want to enable data resiliency and shock protection capabilities. Once the data is stored in the Kafka cluster, then we take the data and process it in different end stores based on the velocity, value, and variety. That's where we have, as you can see in the architecture, real-time aggregation stores, log stores, and analytics data store, which is running on Hadoop. Then our users, which come in all shapes and sizes, anywhere from sales, product, marketing, and engineers, use a variety of tools to peruse and use this data. So as you can see, we have Kibana for Elasticsearch, Hive, and loosely Presto for running ad hoc queries. We have Statusful, which is a Box open source product for looking at open source telemetry data around the monitoring framework. And then we also use Tableau, which is primarily used by business analysts to look into Redshift and check out their queries. What we found was that as we were onboarding more and more tools, our users were complaining that they did not have the visibility that they wanted to be able to debug, to solve the challenges, to look at the queries, to look at the optimizations and problems. Okay? So it became very evident to us early on that the practices that we employed earlier on by scaling our cluster, by adding nodes, by adding these tools, were no longer going to suffice to help users as we grow 1x, 10x to 10x. And we should do something around exposing visibility into our Hadoop data warehouse where users can self-help themselves. So that's where I have a box here showing a self-serve app, and I'll walk you through the thought process that we employed in navigating and selecting an application which can help us give increased visibility into what's happening in our data warehouse. There are many challenges. As you go over the spectrum and you expose the Hadoop data warehouse to a large variety of users, you'll find that users will complain that I do not know if my job is going to, if suppose they're storing some data, and now you are querying that data, the users will ask, how can I be confident that my job is going to finish on time? What are the productivity killers that I should be aware of in my job? What data sets this job will touch? Which user is most active? And based on how we are using the data warehouse over time, what techniques should we employ? Should we blindly just add nodes to our cluster? Or should we instead look at which tables are more hot, cold, and warm, and come up with a comprehensive multi-tiered strategy to then enforce retention sometimes, perhaps, right? Our focus is that we want to have a very, very calculated cost-to-serve model. And the cost-to-serve model should not only include scaling the data warehouse, but also should include some introspection capabilities into how users are storing and using or sometimes abusing the data so we can make informed choices. Okay? So we looked at a variety of approaches to promote self-serve within the organization. We thought we could build something that would be very box-centric in terms of the use cases that we want to ultimately attack, and it would take a number of months. Or we could go across the industry and find solutions that would address some sort of these challenges, but what we found was no single solution was meeting all the challenges that we were seeing in our cluster, right? So while we were in this dilemma, we came across Unravel team, and they have some expertise and background on optimizing the workloads. They're coming out of the Duke University. So we decided to partner with them and kind of see if we can jointly develop the roadmap and by virtue of their product to help solve these challenges. Because what we're thinking is these challenges are not unique to Box. As more and more users adopt on your data warehouse, as your growth increases, you'll want to solve some of these challenges, right? So we decided to partner with Unravel, and the second part of this talk is now going to be mostly focused on how we're using Unravel to solve some of these challenges that we think are worth addressing. So as part of this partnership, we decided to club our requirement into some important buckets. We wanted to improve visibility into what our users were doing, so self-serve was very important. We also wanted a single pane where ops can then log in and see what's happening inside the cluster. And this may mean that you identify action item that you should take, or it may mean that you look at productivity killers. It may mean a number of different things, and we'll talk about how we approach that angle. We also wanted to loosely enforce the notion of data governance. We wanted to see what data sets were being used more actively than the others, and we wanted to come up with a multi-tiered policy where our management can see the return of the money that we're spending on the Hadoop cluster to how the users are using it. And lastly, we wanted to further our DevOps engagement model where users and ops come together to educate each other, to learn from each other, and essentially promote the DevOps vision within the company. So implementing self-serve, that's the first bucket that we created for ourselves. The challenge is that in any DevOps organization, we talk a lot about shift-left approach. So we thought that it was very important for us in the ops organization not to become the gatekeeper of all problems and solution providers, but essentially approach it as a shift-left approach and enable the users to help themselves. We wanted users to have a complete 360-degree view of how they're using the cluster so they can help themselves, okay? So along that, we decided that we should have some requirements. And the requirements were that in order to achieve the data democracy that we're planning on achieving at Box, we really should approach it in a multi-tiered fashion. We should provide appropriate tools to the organization, and they come in multiple flavors. Sometimes it is Hive, sometimes it's Redshift, sometimes it's Presto, sometimes it's Spark. But beyond that, once you identify these tools, then you still need to build expertise in these tools and have introspection capability. How do I best interact with the tool? What is the tool telling me? And how do I go about debugging my problems, right? And that is not a very simple problem to solve because it does require a very, very focused expertise. So one of the goals for self-serve was that we wanted to partner and build product in a way that if you do not have expertise in that area, the platform still can give you some guidance how to go about solving your challenges, okay? And then lastly, we wanted to kind of enable our users to see how their actions ultimately impact other users on the same cluster. So these were our guidelines. And like I said, we wanted to give users a 360 view of the application space and how they're using it. So with the platform that we have in place, our users, in this case, for example, Sandra, is able to log into the cluster, go to the Unravel application, and in a singular 360 view, she can see what query she's running, which is in the right-hand pane, what is the execution DAG of that query, what stages, what actions. She can also click on to find out the stats and bottlenecks within that query. And then lastly, she can see what her query is demanding from the cluster and what is she getting over time, right? So this, in a simplistic view, improves awareness. You can log in, you can see what's going on, and you have some data in a centralized place, okay? We have the capability to bring in job tracker, resource manager, Yarn, Spark-specific logs into a singular view. So now users do not have to go to 10 different places to hunt and collaborate and figure out what it ultimately means. Users can just log into a single pane, and they have all the stats available at their fingertips. This works well, but it works even better when you have some challenges in the cluster. So now Michael logs into the cluster, and he runs a query. And the platform tells Michael that looks like that your query ran for a very large amount of time. In this case, it's over 1 day. And we give some relevant feedback to the user. In this case, we indicate that you have data skew problem in reducers, and maybe you should tinker with some Hive parameters and see if those would help you, okay? So the user then takes these recommendations, applies those Hive recommended settings inside his query, reruns them, and is able to drastically cut the performance impact from days to hours, okay? So this is how we approach self-serve, that without minimal ops touch, users are able to log on, users are able to see their queries, build a holistic overview, and then able to be self-aware and help themselves solve the challenges. Even better, now multiple users have an increased awareness of how their action impact other users on the cluster. You could see, if you're running a query where you're doing data spillages, if you're starting the reducers before your data is available, you're going to waste precious resources on the cluster. These are resources that could have been used by other queries on the same cluster. So actions have consequences. And what we've managed to show here is that by, again, having a singular view pane, users can see that if I'm doing this, what could be the impact on the cluster, okay? So to wrap this part up, for self-serve, it's very important to enable users to help themselves, to give them a single unified view pane where they can see all their activity. And if they still are curious, they can reach into the ops team to help them debug their job, but that is no longer the case for every single query. Which brings me now to the next important thing, ops proactivity. So we built the self-serve for the users. Users can log in and help themselves. This is great. But this is not ultimately what we get paid for. Our value to the organization is we make sure that our infrastructure is always up, performant, scalable, and is meeting the SLAs and requirements that we set out for this particular cluster. So we wanted to build out a capability where we still love our users, we still trust them, but we want to have an oversight on them. We want to make sure that they don't have runaway workloads, which ultimately impact the SLAs, which cause escalations, which impact our sleep score at night. So we wanted to then build a self-serve, self-help for ops organization also. So within the platform, then we focused on how can we bring all relevant events and details into a singular pane, again, centered towards the ops folks at this point in time. So in this view, what we're doing is we have all relevant cluster activity in a singular pane. We are projecting smart alerts where you can log in and you can see where do I need to focus my attention for the day. As a matter of fact, I log in every day in the morning just before driving to work to see if there's any action items that Unravel is telling me that I should fix, or otherwise it'll become a major escalation. We also have a concept of leaderboards. So we can log into the cluster and we can see how our data is moving its states. Is the data hot, warm, cold? What data sets are accessed more often? And if there's any optimizations we can apply across those data sets. And lastly, we also have a capability now to see if we have different queues, and if there are jobs running in different queues, is there a problem where we will end up missing some SLAs for well-defined workloads? In this case, the ETL workload. Same cluster that we use for both ad hoc and scheduled workloads. And we want to be mindful of the fact that users oftentimes will run queries that will impact the SLAs. And sometimes the best choice is to go about and identify those queries and snipe them. But oftentimes, the approach is to identify these queries and just slow them down a little bit, where they still run with restricted resources, just enough so your scheduled higher priority workloads can finish on time. So again, the singular pane is a self-serve screen for ops to log in and focus their attention on the most important challenges for the day. We also have a dashboard where we can see what are the most common inefficiencies in the cluster. And for now, we've chosen to club them into different categories, like if there are parallelism problems, if there are resource wastages, are the queries incurring excessive weight? Do we have load imbalance issues? Do you have a classical large Hadoop, large number of small files, Hadoop problem, and so on and so forth. So this is a very customizable platform where you can log in and you can club these queries or patterns and see what's going on in your cluster. And again, the idea is self-serve for ops. You can log in, you can click on these interfaces, and drill down and focus your energy where you really should be focusing. So for the next session, I'll invite David to go over the data governance part.
Thanks. So data governance. What is data governance? And different companies or different people, they have a different idea about what data governance is. Let me talk about how we define data governance at Box. So we live in a digital world. The data is exploding. It's a big challenge for us because we do not want to simply add more nodes to add the capacity. It's easy to add more nodes in Hadoop cluster, but we want to find a better way, an intelligent way, an economical way to scale out our infrastructure. Now, how do we do it? Box is a data-driven company. We collect a lot of data. In this case, we collect about the data, how we use the Hadoop data set, when, by whom, at what frequency. With this information, we can label our data. We can categorize the data as hot, warm, and cold. And then we can enforce the retention. We can, if no one is using the data, we can just delete the data, get rid of the data. But if it's still being used, we can aggregate the data. So by doing this, we reduce our spending. It's very critical. We want to reduce the spending. And also with the information we collected, we provide an audit trail. Now, how do we define the data label? Here, as an example, we can see, okay, we define we categorize the hot of the data set if it has been accessed in the last 14 days. With a similar criteria, we define hot, warm, and cold. Once we have this defined, we can have the visibility, we can have the insight of our data. We use Hive. Now, we know how each table is accessed, when, at what frequency, how much resource is consumed, and also the data label. Hive supports partitions for better performance. By drill down each table, we also have a partition level view. We know how each partition is used. With this information, we can enforce the data, very complex data retention policy. We can reduce the spending. With this information, we can implement our data governance strategy. With this information, we can scale out our infrastructure in a cost-effective way. Okay, back to you.
Thanks. Oops. Thanks, David. So this brings us to the last part of our presentation, is how do we go about improving DevOps collaboration. So if you recall, we talked about how do we enable self-serve for our users. Then we talked about how do we enable self-serve for ops. And then data governance plays an important role. But what's even more important, that we do not want to segment both parties, say ops, you do your stuff, and dev, you do your stuff. Ultimately, we want to be in an environment where users help themselves, but definitely there's strong value in both dev and ops organizations working together to learn, to help each other, to document the best practices, and then these become a statement of record for new users to come in and learn. So in order to promote that, we essentially set out some goals for ourselves. And the goals were that we wanted to have more data-driven discussions around our workloads. And we think it's important because this helps you rein in your mean time to recovery. The longer you don't know what's causing these workload inefficiencies, you can miss your SLAs, you can have other ramifications in your cluster. So by having a statement of record where we can identify queries and people can work together and debug them, you are using the whole organization. Secondarily, self-serve is good, but we want to reinforce this good behavior by sending folks daily email digests, where people who run the queries, end of the day or next day, they get email digests which tell them, here is your workload view for the day. These were good queries, these were bad queries, and maybe these are the activities that you should take so your workloads are becoming even more efficient. And last but least, this kind of collaboration does improve the DevOps model that we are chasing inside Box. So to give you an example, David is one of our engineering folks. He was running a workload, and he reached into us saying that, even though there are 80 nodes allocated to my job is not finishing in the time I expected. We looked into Unravel. We looked into our OpenTSDB time series tool, and then we saw that even though the user was running these queries, there was barely any CPU registered on the nodes. What could be going wrong? So we told the user, hey, look, looks like your tasks are not really using much CPU. Maybe there's some optimization to be done. And then jointly, we logged into the platform, and Unravel was able to tell us that maybe there is value in adjusting the split sizes. And the problem here was that we did not have a small enough split size to be able to run more tasks and therefore run CPU harder to achieve the job or finish the job in a quicker fashion. These kind of patterns we see repeat again and again, where people will come in and they will want to know what they can do, And as more and more users use the system, they become more accustomed to self-helping and self-serving themselves. But for new users who do not understand the system very well, we want to provide them with a pane where they can come and ask these questions, collaborate with us, and ops will help them become more productive. Secondarily, this creates a loop where people are more engaged, people see common optimizations, people can learn from each other, and then we are maintaining some knowledge base, which showcases that if you ran this query and these were the problems, refer to this article, and maybe this is what you don't want to do next time. Our first attempt at the email digest is we basically club important queries, both good and bad, as well as your resources that you're using on the cluster. And this is good because this reinforces if there are any problems, you will get a digest next day and you'll see, okay, I ran these queries and these queries were suffering because of these problems. We also have an ops-centric digest, which comes in and we identify these were the 5 worst performing users in your system. And then we independently reach into them and we're like, okay, these were the queries, how can you optimize them better? Okay, so we feel that this closes the loop very nicely, where in addition to self-serve and proactivity, we're rewarding good behavior and we're following within the organization to set up some standards. To sum it up, the 4 categories that we set out to accomplish were implement self-serve, enable proactive ops, enforce data governance, and promote the DevOps collaboration within the organization. I'm happy to report that our users like it. The platform is very extendable as more and more use cases are coming in from users. How can they use this platform to solve challenges across different toolings, like, for example, Spark, Presto, maybe even Elasticsearch. We have a plugin modular architecture where it's very easy to bring in additional visibilities into these emerging workloads. I'm personally very happy that this self-serve application has enabled our team to have a better sleep score. For those of you who are in the ops organization, you know that every night you get so many alerts, and as you have an explosive growth, these challenges only continue to increase. So that sums up the talk portion of our talk. At Box, we are continuing to attack interesting challenges in the whole data infrastructure. If this interests you, definitely reach out to us so we can help you solve similar challenges, but most importantly, Box and Unravel team is co-presenting after the lunch break how we're using similar approach to solving Spark workloads. Do reach into us or the team, Unravel team in the sponsor pavilion, ask them what their vision is around this product, how can this be extended to solve your use cases, and thereby we can improve overall self-serve capabilities for a variety of workloads. At this point in time, I'm happy to take any questions. We have mics on both sides, so kindly reach into that, and we'll do our best.
In the governance part, there was like hot, warm, and cold. How you guys manage that? Like, so if something is hot, how you guys give more juice to that hot stuff so that it comes faster? So how you throttle the response for that 3 categories?
So the question is, how do we really optimize the data governance around hot, warm, and cold, and what kind of strategies we employ? So our first forte into that was just labeling data with the Hive metastore information to be able to find what data sets are more often used, what are less often used, and you can customize these policies, right? Where we want to go is we want to come up with a data lineage and data governance and data standard enforcement, so you have a holistic overview. Right now, we do not have this capability where if certain tables are running hot, then maybe you can create an additional copy of that data and store it somewhere else in the cluster. We could do that, but our first approach was more centered towards how do we identify what data sets are accessed more often, and therefore we should have a longer retention for them. Yes, sir.
Approximately how long from when you started initiating the project to when you had a working model like this? Was this a multi-month project with Unravel, or years, or?
Yeah, interesting. So We started this late last year. And basically, the first requirement was we just want increased visibility into how the user workloads are happening. And along the way, we discovered that maybe there is value in building additional visibility views, ops-centric view, user-centric view, data governance-centric view. We are also working on a data protection workload view where, for example, users can specify based on these criteria, throttle down all the ad hoc queries so my ETL workload can get the bulk of our resources. So I would say we're probably like 8-9 months into the cycle at this point in time. And initially, it took a little bit longer to kind of come up with a vision. But since then, we've literally accelerated in onboarding new technologies and new use cases.
And if I could ask a second question, is this Hive specific right now, or is this work for like anything your users are doing on the cluster? I assumed it was general, but then I heard you're doing the Spark one separately. So,
yeah, this is excellent. So the question is this Hive specific, or this could be extended? So it is a very modular architecture. Hive was our first seed app, and the reason being that most of our data is in the Hadoop that business analysts come in and look at raw data using Hive. But the second use case for onboarding is Spark, and I feel that the platform is extendable in such a way that if you want to go across Presto, Elastic, all the inklings are there. You just need to build connectors and kind of start using this infrastructure.
Hey there. Early on, you showed a solutions diagram, the very first couple of slides, and you had time series database there, and just wanted to understand a little bit about how you make use of the time series database, as well as what underlying technology is that? Is that basically HBase or something bespoke that you have?
Excellent question. So the question is, how do we use the time series database? Basically, we have OpenTSDB running on top of HBase, and we're collecting both host-level data as well as event-centric data. This is data about you guys as customers. You use Box, we get upload count, download count, preview count, a lot of metrics. And all these metrics are individually stored as time series in OpenTSDB database, off of which then we go ahead and have some app-centric dashboards that tell us week-over-week pattern anomalies and things like that. So yes, it's OpenTSDB on HBase.
And why OpenTSDB and not just straight HBase?
OpenTSDB is a specialized schema on top of HBase. So if you were to go and implement, are you asking, should we implement?
No, I mean, I understand the difference, but was there a specific, do you find advantage in using OpenTSDB?
Is there a particular, you're asking, is there a particular advantage?
Yep.
So OpenTSDB is optimized for essentially storing and querying data in large volumes, right? And the whole art behind that is coming up with row keys that map to your user case, right? So we feel that if you were to go store it in let's say, Hadoop, for example, and not HBase, we would not have this random lookup capability. We will also not be able to limit our scans. We will have to scan all of the data, bring it together, and then discard it. So with a HBase-centric view within OpenTSDB, we have point-in-time capability to bring in and percolate important metrics.
Well, thank you.
Hi. So my question is around the ETL jobs that are running to build the data warehouse. So I wanted to know they are written in what, like how, in what language, or how the ETL jobs are designed, and do they use Hive all the time, or something else is built? So what is the how the design has happened?
There is unfortunately no straightforward answer, but I'll tell you how we're doing these. So most of our ETL workloads are a combination of Java MapReduce and Hive. I would say more geared towards Hive. Where we're moving towards is we want to expose the self-ETL functionality to the business organizations. That is, the engineering organization should not be tasked with writing code and maintaining ETL. We want to shift this upstream. So if a BI function comes in and say they want to aggregate and they want another functionality added around ETL, there are tools available for that too. So as of right now, we have a combination of Java and Hive. I would say 80% Hive. That's why we focus primarily on the Hive work case with Unravel.
Okay. But then do you do all the data warehouse capabilities like slowly changing dimensions and all that? Like all that is possible, or is it done? Or is it just, straight getting the aggregations and metric counts and this and that? Or do you guys do that as well?
Yes, so we have MySQL, which has some of these data sets centered around user activity stored.
Okay.
We nightly pull in this data. We have our event data. We dedupe in the Hadoop infrastructure. And then we generate Hive tables, and we also generate some aggregates.
Okay.
Aggregates we upload to Redshift. The raw events we store in Hive.
Okay.
So users, depending on what they're looking for, can go to the right store and query that.
Okay. Okay. But primarily SCD, are you doing slowly changing dimensions like type 2, like, where you expire one row and insert a new row for for your user dimensions, like, all that is happening?
I think so. So
okay.
primarily that is stored in the MySQL, but it is brought into Hadoop at the time of nightly ETL.
Okay.
Yeah, thanks.
Hi. Thank you for the talk. I think one of the last slides you showed was metrics, like 98% self-service BI and stuff. How do you measure those? I mean, what kind of?
So let me go back. Right here, right?
Yep.
So as you can see, so what does self-serve mean? So we want to see how much time we're spending debugging. So we have 40% run the business time allocated in our work budget, where we want to focus on just making sure that site is up and we're optimizing and fixing problems, right? So we have seen drastic reduction in that time, and we can use the run the business allocation of time to solve other challenges. Similarly, we measure ops engagement by how many tickets the tier 1 function generates for us. So ever since we created these, users no longer come to us and ask us, okay, my Hive query is running slow. They can help themselves, which leads itself to, it exhibits itself by fewer Jira tickets for us, right? For data governance, David talked about that we're seeing an incremental growth, or exponential growth rather. So what is the money we're spending year over year, quarter over quarter, for scaling and serving our organization? So that is a 4x factor, and then of course sleep is, you can see how many interrupts you have throughout the night.
So the 98% is for the ops team. Is that 98% add the developer who's writing the Hive queries too?
So this self-serve time for now is primarily centered around how much interrupt we as an ops organization get, but I would suppose it is very easy to quantify it from that perspective also.
Thank you.
Sure.
I just had a quick question about the entire backing support system behind this. Is that architecture diagram you showed in like the first or second slide there with the OpenTSDB and Logstash and everything like that? Is that what's backing all the data sets that we're seeing on these dashboards, or is it something else?
So for the data sets that we showed in this presentation, they are persisted in a MySQL schema.
Okay.
But we do have different stores for different kinds of events. And then we have views on top of that. We talked about Kibana, we talked about Hive, we talked about Status Wolf, and then lastly, Unravel centered view about the self-serve and proactivity, right? But the Unravel centered events are stored in its own MySQL schema.
Okay, so so there's something else that's kind of importing into Unravel then?
Right, so we intercept these data sets in multiple ways. Most of them in this simplistic view come from Hive, so we intercept using Hive hooks before and after what's happening to build the information. And then we bring into this MySQL engine where we do some processing, and then you can query and forecast some of that stuff.
Cool. Thank you.
Sure.
I have a question about that 1% CPU use case that the example slide is showed.
Sure.
I came a bit late to the talk. I'm sorry about that. So I might have missed it. How do you? So for example, let's say there's a Hive job running with X number of mappers, 100 users. So and it has a container, assuming you're running through Yarn. And how do you get that CPU percentage per container or per job?
So this particular example is not Yarn centric. This is MR1 centric.
Gotcha.
So like I said, we collect all these data sets in OpenTSDB. Okay. So when the job was running, we were able to see on the node it was running what kind of CPU we were incurring. Okay. And then we traced it back to the platform to see how many maps and how many. I showed in, I think, the third or fourth slide where we had demand versus supply. Okay. Maybe you saw that, maybe you didn't. But tying that, we can see, what are the resources allocated to the job to what's available on the node and cluster. And then we were essentially deep diving, diagging the job and seeing what the platform is telling us could be the potential problems. So the back-end algorithm for this is constantly reworked by the Unravel team to give more relevant insights, and that's a continuous work.
So, yeah, so I'm assuming when the high work for the, where you're saying inefficient joins and small files, everything. So right now it's like a hard set of rules that comes from a Hive expert saying these are the areas where the developer might, do something wrong with a Hive query. So it's a hard set of rules, or is it something that you collect the data and then you look into the data and then you create those rules?
It's actually loosely both, but it's more centered towards that there is a body of information which profiles common set of queries, and then you come across what patterns and anti-patterns exist on this data set, right? But then we self-learn about how our users are using and what. So for example, if you run just one query, you'll get one value to tune. But if you run thousands of those queries and over time those values converge, that maybe 0.08 is the right value for a parameter. So it's a little bit of self-learning environment on the back end, but I agree with what you're saying that this needs to be a combination of both.
Since nobody is here, I'm going to ask you 2 more questions.
We have just 1 minute left, so go for it.
Okay, I'll just skip the first one. There was a presentation at Twitter, and they were talking about how to fix their Hadoop environment. And they was one of the points they made was there's no way you can fix things without knowing what's happening inside a cluster. So they switched on the HProf that comes with MapReduce, and then they profile their whole system, and then they figured out things that nobody could have guessed in a million years. So any idea about, if you have listened to the Twitter, any idea about implementing in your system, or whether it will help a Devops team to look into a Java stack frame stuff and figure out where it's taking too much time and all this stuff?
Can you rephrase your question again so I have a little bit more insight? Sorry.
If it's too late, we can take it out if you want.
Maybe let's do that.
Sure.
Definitely.
So thank you for the answers.
Thank you.
Thank you for the